Okay. Uh, can I just get confirmation you can hear me and see VS Code on the left and the class website on the right? Okay, thank you. Okay, so the first thing we're going to do is bring down a container, a Postgres container. We're going to use docker compose by ML. We're going to list our service. We're going to call it database service, and we're going to use an image from Docker Hub. And let's just check out what Docker Hub offers. And we'll just use that. Most things don't change too much, maybe just the advanced features. But, so this version should be good. Yeah, that might be good enough. So pull down our image or Docker compose pull, and it should already be pulled down prior. Good. Okay. So we have the image downloaded to our computer. Now we gotta run it. But there's some configurations, and if you read through the README, you'll find that we need to set a password and a user and a database name. And to do that, you use environment variables. So this image by design, or the Postgres team designed it to read in environment variables. So again, environment variables are a very common way of configuring containers and things in the cloud. Um, so it's good to get used to using them. So Docker Compose allows us to list each environment separately. But my personal preference is just to use a file. That way you can group your environment variables um, into something that, your application might have a set of environment variables and your database might have a set of environment variables. So that's just personal preference, and we'll just go with that. So we'll create a file called database env, and in it we'll set our credentials and database. But I guess I should also go through here. So we're kind of doing the same steps. So we just did this, and I'll talk about the volumes a little bit later. And now we're in this step where we're gonna set the unicorn. So that way, at least you can, when you go through the tutorial, it'll be at least familiar. Sorry, I should have started with that earlier. But hopefully it's not too late. Okay, so we're gonna set our username. We'll call it the unicorn user, and we'll say we have a magical password, and we'll call our database Rainbow. So now if we do Docker Compose up, hopefully we'll get to a point where the database comes up. I guess let's see it fail first. Okay, so we do Docker compose up. Without setting the environment variables. It's complaining that you must specify it. So now let's inject the environment variables into the container via Docker compose. And now if we were to run it, hopefully it'll consider itself properly configured. And the database system is ready to accept connections, so that's always a good sign. So now we want to connect to the database. So most times without a container, you would just you will have to install this client on your host machine and use that to connect to local hosts. But because we're in containers, we can just run another instance of this container. So I'm gonna start a new one. I don't think there's much information in that log, so we're gonna say docker compose run database bash. And here we have a second container running. Okay. So we're going to use this second container to connect to the first container that's actually running the database. The second container is just running a shell. But the good part is that the database has this client command line tool. So we don't have to install anything new or use a different container. We use the same image. Okay, so we're in here. And a lot of these databases, they have graphical interfaces. So you can download something and connect to the database, and then you can do click things. But since we don't do too much, and most of this is abstracted away with Django, I won't go into that. But if you want to dive deeper into databases, those tools are great, and at least that's an avenue for you. Okay, so we're going to use this command line tool. We're going to tell us where the database is running, and Docker Compose runs each image as a container, runs each container, and gives it a host name based on the service name. So in this case, the service name is database. That's where the remote database is running as. This is the username we specified here, unicorn user, and then the database name is rainbow database, and they'll ask us for our password. I think there's a way to pass in your password too, but we'll just do it this way. Many ways of doing this, because if you're scripting something, you're not going to interactively enter in the password. So there's different ways of entering in the password. But we'll just do it manually. So here are the prompt changes. So we're in the database now. So one of the first things we want to do is to create a table in our database. So let's just check what table exists. So there's no tables right now. We're going to use the SQL command. So SQL is the language that most SQL databases understand. So I think create and table are keywords. It can be upper or lowercase. But we'll just signify it as uppercase here. So this is the name of the table we'll create within our Rainbow database, which is a database within Postgres. Again, back in the day, we didn't have the luxury of containers, and you don't want to keep on installing Postgres, so you install Postgres once and just have multiple databases inside of it. But now with containers, we can spin up multiple containers of Postgres, so we really don't need multiple databases within Postgres, but it is a feature. Okay, so within this color table, we're going to make a column called name of the color, and then this column will hold text data. And then the semicolon, I believe, is important. So here, it didn't error out, and if we were to check our tables, you'll see the color table being created. So now let's read and write to the data to the table. So this is kind of how you query. You select, and I think these are columns. So we're going to select all columns from the color table. Can't remember if it's column or rows. I think it's column. So right now the table is empty. There's no rows inside. So we're going to insert our first row of data. Insert into our color table the values of pink being our first color. And the single quotes is important. Here, I forget what the 0 meant, but I think that's one row was inserted. And if we were to select again, we'll see our pink. And if we want to add another color, you'll see there's 2 rows now. Okay, so that ends this article, because the intent of this article was really getting Postgres installed, and this is a quick and easy way to check that Postgres works. But for us, we're gonna do more of the CRUD. So I'm gonna go through actually updating and deleting. So to modify data is update the color table. I'm going to set the name to hot pink for every row where the name is currently pink. So one row was updated. If we are to check our table, pink has changed to hot pink. So you notice that the database doesn't ask for confirmation. It doesn't show you like what's gonna change. It just does it. So the command line is very unforgiving. If you have multiple pinks, like all of the rows with the name pink will have changed to hot pink. So that's why some of the GUI tools are more forgiving. They'll probably have more confirmations and like, hey, you're about to change these rows maybe. I actually don't use it too often, so I would think that's some features they might put in, but I'm not sure. But definitely from the command line, you don't have any guardrails. There is no undo, so be careful, and that's why we typically use like libraries to interface with databases. It just saves some headaches. Okay, so we've updated. Now let's just delete. We'll delete from our color table where name equals hot pink. So we check again. It's deleted. If we delete something that's not there, it'll have a 0. And I think if it's not exact, it won't delete it either. So it's very picky. It's like writing code. Okay, so we're back to an empty database. Now let's do a simple join. A join, again, is when we relate two tables together. So I hope you noticed that we created a table called color table. We gave one of the columns name is name, and then we had pink as one row, and then purple as another row. Okay, so that's what we did. Now we're going to create a second table, and then join the two data. All right, so let's actually talk about it some more here. So what we're going to try to do on slide 10 here. Okay, so we're gonna have two tables. One of them being the color table, and the other one is a pony table. And you can think of, each table is kind of a list of ponies and a list of colors, because that's what each row is, right? And right now the color table has this name column. And then we're going to add another column to this color table, and we'll call it the pony name. So this contrived example is kind of like we're going to have a color, and that color belongs to kind of a pony. And then we're going to create this other pony table, and we're going to have two columns. One is the name of the pony, and then the second column will be the skill of the pony. So name and skill. I don't know if you're familiar with My Little Pony. I think when I first started working on this class, my daughter was that age, so that's how I came up with these examples. But she no longer cares about My Little Pony, so it's a shame. But aside from that, so we're gonna have two tables, and then we're gonna start adding data. So we're gonna add rainbow as the first row, and rainbow is going to belong to rainbow dash, and then the second color will be purple, and that color will belong to twilight sparkle. And then we're going to add our ponies. So the first pony will be twilight sparkle, and then her skill will be studious. And then the second pony will be rainbow dash, and then her skill will be speed. And then when we join, once we join the two tables, we can say that this first row of data, this blue row, correlates with this second row. And then similarly, this green row will correlate with this green row. So we can actually say, the color purple belongs to a pony that has a skill of being studious. So that's how you can like merge data together with these joins. And right here, it is hard to see. I guess so one of the benefits of doing this is if we had another color, gold or something, which for some reason was added to rainbow dash, it can also be related to the same row, so that we can say the pony with speed has the colors rainbow and gold. And if we ever decide to add another skill to rainbow dash, like speed and I don't know, sonic boom or something, we can add the skill, change this one column under skill, this one cell, and all the colors will be related to this new skill, without needing to, if we have one big table, and then we had, rainbow and gold, and then in one of the columns it was the skill. So it will be speed initially, and then if we were to add skill, it was speed, and then if we need to add sonic boom, we have to like go through every row and add sonic boom to it. So plus sonic boom, and there's a lot of duplicate data. So with this relational, you can change it in one place, and it's like changing it for every row. So it's kind of like, it's called database normalization. So if you want to understand more about that, I'll post it to the chat. So it just allows you to optimize the database a little bit more, and reduce duplication. And what if when you went back to add sonic boom, you accidentally missed one of these rows, then your data is kind of out of sync. So it's just safer and more robust. Normally, we wouldn't use the name. We'll use IDs, but I figured the name is just easier for demonstration purposes, because you'll probably use an ID here and an ID here, and then the name of the pony you'll actually have a separate column for. So if the name changes, you don't have to change all these columns. You just change it in the column of the normalized table. Okay, but so yeah, so these two columns typically are IDs and primary keys and foreign keys, not text, but we're using text there just for demonstration purposes. Okay, so we're gonna do that now. Okay, so we're gonna alter our table named color table and add a column called pony name that has text data. And then if we were to check out our color table, you'll see there's two columns now. So let's do the next step. We'll create a table called a pony table of ponies. List the ponies. And in this table, there's a name column, which has text information, and a skill column, which has text information or data. So we were to select everything from the pony table. You'll see that we have the name and the skill, and both tables are blank. So now we're going to add in the data. So insert into the color table a row with values of rainbow for the name of the color and rainbow dash for the name of the pony. And we'll do the same thing. This time we will add in purple as the color and Twilight Sparkle as the pony name. So we check our color table. That's the data we added. So now let's add into the pony table a row with the values of Twilight Sparkle as the name of the pony, and Studious being the skill. And then next one will be Rainbow Dash as the name of the pony, and then Speed being the skill. And when we check the pony table, there's our data. So now let's do the actual join. So we're going to select everything from the color table, join it with the pony table, and then the foreign and IDs and primary keys we're going to use to correlate the two tables is from the pony table, we're going to use the name column, and that needs to match the pony name column from the color table. Okay, so here's our join table, and you'll see that the rainbow color belongs to Rainbow Dash, and who has the speed skill. Purple belongs to Twilight Sparkle, who is studious. And on the joins, there's if you want to get into it, there's inner joins, outer joins, and left and right. So it's really just a Venn diagram, like where it intersects. Where one column, one table has a role. Say one table has a color for Twilight Sparkle, and another table didn't have a skill for Twilight Sparkle. So that's what it is. Like if you want to, when you have more complex data, that comes into play. But for this simple example, it's really not a big deal. Or it doesn't show this kind of intersection, sets, and Venn diagram. But it's there. So joins can get more complex. when you need it to be. Okay, so the last thing, and I've run over, so feel free to head out. Um, so the last thing is persisting data. If we were to exit out of this container, or exit out of the database, exit out the container, do a Docker compose down. So yeah, there was nothing in the logs that showed, we were just showing that we connected, but yeah. Okay, so now we bring the database back up. And we spin up another container to connect to the database. Oh, wow. That's nice. And then it was magical password. So we check our tables. They're all gone because everything was written to the file system. In the file system, any changes to the file system other than what's in the image or in our Docker file, it is gone. So in order for the data to persist, we need to kind of make sure that the files that's needed to capture our data doesn't just go away. So to do that, we'll go back to up here. We use this volumes. Okay. So the first way to do it is to say in our current folder on the host, we'll make a folder name data. So here's our data. So that's one way. So we were to Docker compose up. Oh wait, I should down it first. Down it. Now we do up. When Postgres spins up, it should create all of its data files. And then, so yeah, this is all the data files that's Postgres using or generated. And then to know where this file is, you kind of need to understand Postgres. And usually in the documentation, they should tell you data. Yeah, so it tells you where you can specify where the data lives. Okay. Okay, so that's one way. So now, if we were to connect to the database, oh, dang it. Um, okay, sorry, coming back up. And here we'll connect to the database. That. And copy this. And that's the password. And we'll see that there's no tables, so we'll create our first table. And then that's our table. And if we're to exit, do a Docker compose down. And then if we were to bring it back up, and then log into the database again, I might have jumped the gun. Okay, I should just slow down. Okay, Docker network. So I want to remove it. Let's see this. Let's down it first. Okay. So now we want to remove this. Docker network. Remove that one. And then let's remove this as well. Okay, so don't rush Docker Compose. Compose down. Okay, so we go back up. But with all that, the data files are still here. So I'm still expecting that when we log into Postgres, our data is still there. And let's go copy our command. Magical password. Check our tables, and still there. Because the files that has all our data didn't get blown away when the containers got blown away. But you notice that even if we continue blowing away our containers and adding it, the data won't go away unless we actually delete this folder. So my preference is to not manage this folder and instead let Docker Compose manage kind of like a network shared file or network shared folder. And so that instead of remembering to delete that data folder each and every time, Docker Compose will delete it for us. So to do that, we're gonna specify a volumes, give it a name of Docker database data, and then instead of mounting our host data folder to the container, we're gonna mount this database data volume onto a container. So if we are to do Docker Compose down now, go back here and up, and I will wait until it's fully ready. Okay, so that's good enough. Go into our another container to connect to our database. Connect to our database. Magical password. Verify nothing's there. Create our table. Verify is there. And if we were to Docker Compose down, and that's done. And if we were to bring it back up, and we were to connect to it, oops, magical password. our data is still there. So now, how do you actually get rid of the data? So instead of needing to remember which folder to delete and possibly deleting something important, all you need to do is do docker compose down and tell it to remove the volumes. The shortcut is -v, but so if you see -v, that's really volume. So now the volume is gone, our data should be gone, and if we bring it back up, okay, the data containers are running. Jump back in here. Magical password, list out tables, is gone. Okay, so exit out the database, exit out the container. So that's much easier than deleting files off your host, which can be scary, because you might actually say something important there at one time, and also you don't want you want your containers to be independent of the host as possible, and this is one way to kind of get it there. All right, so that's that. That's all this article is. And then you hopefully can figure out the models portion based on your experience with Django and these tutorials. So I won't go into that, and I'm going to stop the video and answer any questions. But if if you have nothing to ask, then you're free to go. Thanks for hanging around. Sorry I went over. And yeah, have a good night.